So good morning friends, this is Dr. P. Munaswamy, Professor Department of ECE. Today you can see the main part of the any communication system. So generally you can take the any communication system. There we are going to have the three basic elements. One is the transmitter, receiver and channel. So the purpose of the transmitter is which can transmit the data from source to destination by the process known as a modulation. So based on the modulation techniques, we are going to have three types of the modulations, what we have discussed in previous classes also. So that is the AM modulation, FM modulation, and PM modulation. So there all the modulations can be happened at the transmitter side. So there are three basic elements what we have discussed. So transmitter, receiver and the channel. So the purpose of the transmitter is by the process of modulation, you can transfer the data from source to destination. This is the first one. Second one is the channel. So that is it is a physical or non-physical between the transmitter and receiver. So which can carry the information from the source to destination through channel or through wireless. It may be wire or wireless. So based on the type of the selection of the communication system, so there may be wire communication or there may not be wire communication. So that is the wire and wireless communication. So we are transmitting the data through wire, it is a wire communication. If you are transmitting the data without wire, without any physical contact between the transmitter receiver, it is a wireless communication. So that is the purpose of the channel here. So based on the selection of the communication system, it is a wire communication, there is a physical contact between the transmitter and receiver. Then wireless communication, there is no physical contact between the transmitter and receiver. But there is a physical contact between the source to the transmitter. From the transmitter to receiver, so there should not be any wire or physical contact. So that is wireless communication. Then coming to the main part, which is we are going to discuss now, that is the receivers. So that is the destination which can having the receiver. So what is the receiver? So receiver is electronic device. It is a combination of the different components which can receive the modulated wave or transmitted signal from the transmitter. So by the support of the transmitter, we can transfer the data or transmit the data in terms of the signals, that is the modulated wave. So after modulation, we are going to have the modulated wave. So this modulated wave can be transmitted through wire or wireless. Then the modulated or transmitted wave can be received by the arrangement of the receiver at the destination part. So that is here we are going to take the reverse operation, what is we have taken at the transmitter side. So coming to the transmitter side, we have to take the operation of the modulation. So that is what is the operation in the transmitter side is modulation. Then coming to the receiver side, so here we are going to take the operation which is reverse to the modulation known as a demodulation. So that means, so whatever the signal transmitted, whatever the information is transmitted, the same can be retrieved by the receiver by the operation known as a demodulation. So demodulation is a reverse process to the modulation. So we are taking the modulation operation at the transmitter side, whereas coming to the receiver side, we are going to take the reverse operation known as a demodulation. Now you can see so what is the receiver, what are the basic elements, what are the basic components, what are the basic operations available in this receiver and how it will work, we will discuss now. So these are the main components. So here we are going to take there are two types of the receivers are there in this module. One is the Trf receiver. So that is the tuned radio frequency receiver. Second one is the super heterodyne receiver. So these are the two receivers which we are going to discuss in this chapter. So coming to what are the basic elements, basic parts available in this receiver is, so there is a RF section is there. Another one is there is a characteristics of the frequency and tracking system is there. How we are going to find out the AF frequency, and there is a AGC, automatic gain control is there. So what is the use of this AGC? What are the types? There are two types of the AGC are there, simple AGC and delayed AGC are there. So this is about the related to the receiver AM. Similarly, we are going to take the same the AM receiver with the FM receiver. So that means, so based on generally there are based on the selection of the or generation of the IF frequency, we are going to have the two types of receivers are there. One is the TRF receiver, another one is the superhead driven receiver. Whereas coming to the based on the type of the modulation used or type of the demodulation process used at the receiver side, you can have the there are three types of receivers are there. So similar to our modulation techniques. So coming to the modulation, the AM modulation is there, that is amplitude modulation, frequency modulation, and phase modulation. So that is the based on the type of the modulation. Here also we are going to take the reverse operation of the receiver side. So based on the modulation type, again we classify these receiver into three types. One is the AM receiver. So because the modulation or demodulation takes based on the variation of the amplitude of the carrier signal according to the instantaneous value of the modulating signal. That is the AM modulation. So because you have taken the AM modulation, so the receiver side we have to take the AM receiver side. So that means you are going to take the operation of the reverse, that is demodulation, by the varying the parameter of the amplitude of the carrier signal according to the instantaneous value of the modulating signal. That is AM receiver. Then coming to the another one is FM modulation, the frequency modulation. So based on that we have the classification of the FM receiver. So that is basically we are going to see the, so one is the based on the components or based on generation of the IF frequency, we are going to have the TRF receiver and the superhead. So based on the modulation type used, we can have the three types of receivers are there. Basically we are going to discuss only two receivers. One is the AM receiver, another one is the FM receiver. Okay, so this is about the where we are going to take the in this chapter the discussion. So you know that what is the AM receiver, what is the FM receiver, what is the difference between these receivers. So that means, so what you have discussed, so the AM modulation means AM stands for it is a amplitude modulation. So the amplitude of the carrier signal will be varying according to the instantaneous or strength of the modulating signal. Then the receiver take the same operation here also, so that it is a AM receiver. So we'll see what are the different elements, what are the different demodulation techniques we are going to use while taking the operations of the demodulation of AM. So there are two types of the demodulation techniques are there. One is the square layer detector, another one is the envelope detector. So these are the two techniques or demodulation techniques are used in case of the AM receivers also. So similarly coming to the FM receivers, here also we are going to take the frequency discrimination method and the phase discrimination methods for receiver type of the FM receivers. So we'll see what are the basic advantages. So first one, any receiver have to receive the correct receive concerned modulated wave. So based on the selection of the component of frequency, you can retrieve the concerned demodulated wave, the transmitted wave by the transmitter. The same wave can be selected or tuned by the receiver. Then cost of the receiver should be effective. So if it is cost is more, so it will be somewhat the consumer will be uses of the receiver will be very less. So you have to take it should be economic, the cost will be very less, and also design will be very easy, and also the selection, the tuning of the desired frequency should be in a proper way. So these are the main things we have to consider while selecting any receiver. So another one is there unwanted signals. So suppose the noise or unwanted signals are there. So the receiver is able to reject or remove those unwanted signals and allows the only wanted signals only. So this is about the receiver main properties or features while selecting while designing any type of the receiver. It may be a TRF receiver, or it may be superhead receiver, or it may be based on the modulation techniques. We are going to have the AM receiver and the FM receivers. So the coming to the types of the or classification of the receiver. So that is here. So based on the tuning of the frequency, we are going to have the two types of the receivers are there. One is the TRF receiver, tuned radio frequency receivers, and the TRF we are going to have the two types of receivers are there. One is the regenerative receiver. Another one is the super regenerative receivers. So these two receivers are under the TRF receivers only. Then another type is another one is, so broadly based on the frequency tuning, we are going to have the two types. One is the TRF receiver, another one is super heterodyne receiver. So under the super heterodyne receiver, mainly the whatever the signal received, that is in terms of the radio frequency range. So based on the generation of the local frequency by the arrangement of the local oscillator, the difference between the received radio frequency and the locally generated carrier frequency should be in IF form. So that is intermediate frequency. The difference or multiplication can be in terms of the IF frequency only, intermediate frequency. So that intermediate frequency should be 455 kilohertz only. So it should be always, so whatever the received signal RF range can be tuned to the IF value. So it may be operation of the difference or multiplication, whatever it may be. The difference between the received radio frequency range signal and the locally generated frequency signal, difference should be IF, that is the 455. So that is the basic principle of the super heterodyne receiver. Whereas in case of the TRF receiver, there is no this generation of the IF value. So whereas coming to the super heterodyne, so we are going to heterodyne the taking arrangement of the mixer is there. So by the support of the mixer, we can take the operation of difference or multiplication between the received radio frequency and the locally generated carrier frequency. We'll get the IF value. So this is about the TRF and super heterodyne receiver introduction. Then coming to the what is the operation of the TRF receiver? So what are the basic elements? How it will be operate? So we'll see in this TRF receiver. So we can see this diagram. So there is a antenna is there. So which can receive the correct receiver signal. So that is whatever the signal you have transmitted by the transmitter, the same signal can be tuned or received by the antenna. So once you have the received concerned signal is given to so there are two types of the RF amplifiers are there here. In case of the TRF receiver, so first element is antenna, which can receive the concerned signal. The received signal can be given to as input to the first stage of the RF amplifier. So what is the use of the RF amplifier means? So whatever the signal transmitted with transmitter, it can be travels through the wire or wireless. So while traveling, the signal may be affected by the atmosphere or internal effect is there. So because of this one, so there is a chance of getting the weak signal. So the transmitted signal is a strong signal. So after traveling a long distance through wire or wireless, so it become a weak signal. To increase the strength of the signal, the receiver signal is generally, it is a weak, low signal, low strength. So to increase the strength of the signal, we have to use the RF amplifier. So that is the first and the second stage. So even though the amplification is not increased in a sufficient manner, so you can arrange the another stage of the RF amplifier. So this is based on the requirement. So the arrangement of the first stage and second stage RF amplifiers will be based on the requirement. So with the support of the first stage, we have reached the sufficient energy or sufficient level of the signal, then there is no need of arrangement of the second stage RF amplifier. So based on the signal strength increasing, you have to arrange the 1 or 2 or 3 RF amplifiers. So because why it is RF amplifier means, the received signal is in the RF range only. So while transmitting the signal, while modulating the signal, it should be transmitted in terms of the RF range only. So then only the signal can be traveled. If it is audio frequency range, it will become a very weak signal does not travel a long distance. It will be decayed. The signal can be dies. So that always we are going to transmit the signal in terms of the RF range only, radio frequency range, that is in terms of megahertz only. So that we have to arrange the stage of the amplifier is also RF stage, radio frequency range. So that we are taking these two stages. So along this RF amplifiers, there is a ganged capacitor which is arranged. The combination of the multiple tuning capacitors is known as a ganged capacitors here. So this is the purpose of the ganged capacitors which can tuned to the desired frequency. So the transmitted signal can be properly received. So because of the tuning action by the ganged capacitors. So by the tuning operation of the capacitors, so this tuning can be fine tuning is there, broad tuning is there. So based on the desired frequency reaching, we are going to make this tuning, fine tuning of the ganged capacitors. So we'll get the desired frequency. So once you have these operation signals are received in proper and amplification is taken, then we are going to take the operation of the main, that is the detector, demodulation. So based on the modulation taken at the transmitter side, the same operation, if it is AM modulation, you have to take the demodulation of the AM. If it is a FM modulation, we are going to take the demodulation of the FM. So that is based on the selection of the type of the modulation, we are going to arrange a demodulator or detector here. So that is what is the purpose of the demodulation operation here. So the modulated signal which is available in the radio frequency range, that can be demodulated by the demodulation operation or detection operation. We can tune to the low frequency range. So that is audio frequency range. So whatever the received signal is a radio frequency range, that can be converted into the audio frequency range by the operation of the detector here. So that means, so the transmitted signal, there is a voice signal or sound signal always available in the audio frequency range only. Thus audio frequency range directly we are unable to transmit, so that it can be modulated or increased to the high frequency by the combination of the carrier signal. So then coming to the demodulation operation, the high frequency components can be eliminated and allows only the modulating signal frequency, which is low frequency or audio frequency range. That is a output of our detector here. So the output of the detector is always audio frequency range only. So once you have this one, this again the demodulated signal is a very weak signal. To increase the strength of the signal, we have to go for the audio frequency range amplifier. Whereas coming to the beginning stage received from the antenna, the signal received is a radio frequency range signal, so that we have to arrange a radio frequency range amplifier here. So after the operation of the demodulator or detector, so the detected output is a audio frequency range, low frequency range signal. So that we have to use the amplifier of the audio frequency range only. So once you have the amplification of audio frequency range, then we are going to have the amplification of the audio frequency range signal by the audio frequency amplifier. So once you have the amplification, then we are going to have the power amplifier. So here we are going to increase the power of the signal. Then finally the power amplifier output is going to the speaker, which can produce the sound signal. So here we are going to use the audio frequency range amplifier and power amplifier. So audio signal frequency can be increased by the audio frequency amplifier, whereas the power of the signal can be increased by the power amplifier. So once you have this amplification is over, then we are going to give the output to the speaker, which can generate the sound signal. So this is the process of our basic elements of the Trf receiver. So this is complete operation what we have discussed, all the elements. So what are the basic operations of each and every element? So the basic concept of behind the superhead and receiver. So already we discussed in the beginning. So the basic principle of the superhead and receiver is, here we are going to receive the two types of the signals. So the signal received is a radio frequency range, which is received by the antenna. To make the received radio frequency range into IF value, we have to arrange the locally the carrier signal. So the local oscillator, which can generate the local oscillator, the local carrier signal. So by the operation of the mixing, we are going to have the IF frequency signal generation. So that is the coming to the superhead and receiver. So the basic element along the receiver part, everything. So there is the additional element of the mixing operation. It is known as the mixer. So the main purpose of the mixer is which can perform the operation of the difference or multiplication. You will get the output of the mixer will be IF value. So this is the circuit diagram or the basic diagram of the superhead and receiver. So there is a similar to Trf receiver. So there is a antenna is there. By the operation of the antenna, we are going to receive the desired signal frequency. So there is the combination of the L and C will be act as a tuner. So which can tune to the desired frequency. Then once you have the tuning operation over, then the received signal is weak. To increase the strength of the signal, we are going to have the arrangement of the RF amplifier. So this is the RF amplifier. It is also same as the TRF receiver. Then coming to the next one, so received signal is the AFS signal, standard RF signal. So this is a combination of this is known as a mixer and there is arrangement of the local oscillator. So received RF signal by the support of the gang tuning and the local tuning, whatever it may be. So the received RF signal is given to the one of the input to the mixer. So this is the mixer which is having the two inputs. Another one is the input is from the local oscillator. So which can generate the carrier frequency of the local. So the difference between the FS and the FC, it is a signal frequency received from the antenna. This is the FC stands for the local carrier frequency which is generated by the local oscillator. The difference between the FS and the F0 will give the IF value. So the frequency of this one is known as a IF frequency, intermediate frequency. This frequency signal is given to the amplifier, multi-stage IF amplifier. Here also we are going to increase the strength of the IF signal. So we have to arrange the multiple stages of the IF amplifiers. Then once you have this one, so there is a decoder. Once you have the received signal is in terms of the IF value, then again there is a demodulation operation. So there is arrangement of AGC and IFC, automatic frequency control and automatic gain control circuits are there. We will see in detail. So how it will be works. Automatic gain control, there are two types are there. One is the simple AGC, another one is the delayed AGC. So by the support of this AGC, you can increase the gain of this RF amplifier and the demodulator. So once you have the demodulation operation, we are going to have this output of the noise modulating signal. So what is originally transmitted that can be retrieved or regenerated or reconstructed by using demodulator. So then you have the low pass filter. Is there any high frequency components, that is unwanted signals can be eliminated and allows the only wanted signals. So that is the low pass filter purpose. Then finally there is a audio amplifier is there which can increase the strength of the audio signal. After the demodulation output, the output generated from the demod will be low frequency audio frequency range. So that we have to arrange the audio frequency amplifier which can increase the signal strength. Then there is a power amplifier which can increase the power of the signal, and then finally given to the speaker which can generate the sound signal. So you can easily observe that what is the difference between these two operations, that is the TRF receiver and the super heterodyne receiver. So there is no generation of the IF value, intermediate frequency, in case of the TRF receiver. Whereas coming to this one, there is a generation of the super heterodyne, whatever it may be signal generated or received by the antenna. So that can be converted into the IF value by the support of the locally signal generated, that is FC value. So that is a basic difference you have to observe between the TRF receiver and the super heterodyne receiver. So this is the RF section. You know that it is a combination of the L and C. This is known as the resonance and tank circuit, which can tune to the desired frequency. So this is the RF section, different circuit diagram based on the transistor and the FET based characteristics. So this is the operation of the mixer, what you have discussed. So the received signal is a RF signal. So by the support of the local oscillator, we can have the locally generated carrier signal FC. So we'll get the FC, Fs minus FC will generate the IF value, intermediate frequency. That is the main purpose or use of the mixer or frequency changer or frequency converter. So this is the mixer circuit. So we have the different components are there. So this is the RF, which is received signal. There is a mixer coil is there. So based on that, we are going to have the this is the amplifier circuit is there. The gang tuning is there. So this is the local oscillator which can generate carrier frequency. So by the local oscillator and received signal, we are generating the IF value. Finally, the output of this mixer generates the only IF frequency intermediate. So that means the mixer can have the two inputs what you have seen in the previous diagram also. One from the radio frequency signal RF value, this is another one is the local oscillator signal frequency. So by the combination of the both signals, we can generate the difference. Okay. So this is the there are two different types of the trackers are there. One is the known as a pattern tracking, and then one is trimmer tracking, and 3-point tracking is there. So how the tracking by the support of this gang tune capacitors. So by the support of these three types of methods, that is the pattern and trimmer tracking, a 3-point tracking, we can tune the our desired frequency. So you should not allow the other frequencies. So whatever the desired frequency for this receiver, those signal can be received by using these three types of the pattern tracking and trimmer tracking and the 3-point tracking in case of the mixer. That is the case of the super 8 receiver. This is how you are going to generate the intermediate frequency. Here also you are going to take the received signal RF value and local oscillator is there. The difference signal can be known as IF value, that is intermediate frequency, that can be amplified and get all the outputs. So this is the automatic gain control AGC. It is one of the element in the super 8 receiver. So which can controls the gain of this one. There are two types are there. One is the simple AGC and the delayed AGC. So this is the simple AGC diagram. Here we are going to have the receiver of signal is there, and there is a diode detector is there, and then low pass filter audio amplifier. So once you have this different signal IF value, that can be based on the requirement of the strength. We are going to vary this automatic gain control circuit. So by this we can increase or decrease the gain of the circuit. Then automatically there is improvement of the strength of the received or demodulated signal. This is the delayed AGC. Here also we are going to have the same operation. Additionally, we are going to have the threshold effect is there, adjustment is there. This circuit will be separate. So you can see the difference between the simple AGC automatic gain control and the delayed AGC. This is only there is a threshold adjustment is there. Remaining will be same. So then compared to these AM FM receivers. So these are the main important differences between based on the modulation techniques, AM receiver and FM receiver. In case of the AM receiver, you are going to use the modulation in the AM modulation, whereas coming to the FM, it is a frequency modulation. So the modulation difference between these two is, here we are going to have the carrier signal and modulated wave. Similarly, here also we are going to have carrier wave and modulated wave. So the difference between the only variation is there is the frequency of the carrier will be varies according to the instantaneous value of the modulated FM value. Whereas coming to the AM, so here the amplitude of the carrier signal will be varies according to the instantaneous value of the modulating signal. So that is the difference between the AM receivers and the FM receivers. So bandwidth requirement, you know that. So here we are going to have the 2 times to the FM value, 2 FM, the modulating signal frequency. Here we are going to have the 18 by 15 kHz frequency deviation is there, and bandwidth required 180 kHz. So that is the where we are going to have the differences. So the frequency bandwidth requirement for the FM is more. So because there is a multiple signals are there. So based on the requirement, we are going to have the truncation, that is called Carson rule is there. So based on that, we are going to define the bandwidth of the FM. So zero crossing in case of the modulator, equidistance. So there is no requirement here. Zero crossing in case of the FM wave. So the design, coming to the design of the AM receivers, it is somewhat easy compared to the FM receivers. So these are the basic or fundamental differences between the AM receiver and FM receivers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.